Example 10. A non-uniform rod AB of length 2 meters is supported horizontally on two supports at A and B. The reaction at A and B are 60 Newton and 40 Newton respectively. Find the weight of the rod and the position of its center of gravity. CG. Solution. Since the body is having a reaction 60 Newton at A and 40 Newton at B, we have to get the force F, which is the center of gravity. Clockwise moment is equal to anti-clockwise moment. The sum of the reactions is now equals to the moment. We have that 40 plus 60 or 60 plus 40, which is equals to D times F, which is the distance times the force F, which is the center of gravity. We now do our addition and get 60 plus 40 is 100, which equals to distance, which is the length of the body, which is 2 times the force of gravity F. And for the force of gravity, making F the subject of the formula, will now become 100 over 2, which is 50 Newton. Parallelogram of forces, resultant and equilibrant. Resultant. The resultant of two forces acting at a point is the single force which, acting alone, would produce the same effect as the two forces acting together. Equilibrant. The equilibrant of two forces is single force which keep in equilibrium all the forces acting together. It is also the resultant in magnitude and direction. Equilibrium of two forces acting at a point. If two forces acting at a point are in equilibrium, the diagonal which bisects the parallelogram represents the resultant in magnitude and direction. Then get the formula in figure 1. We have force acting on a truss OB, having S as a vertical component and Q as a horizontal component, P as the resultant. Then II is another diagram showing the parallelogram of force A, B, D, C. The angles inside of the parallelogram A, B, C is 180 minus theta, while the angle at BAD is theta. The resultant of the parallelogram, which represents the magnitude and direction, is R. Then III is when taking the parallelogram by cutting one of the sections of the triangle. Angle ABD is 180 minus theta, where P is opposite to capital R. R is opposite to capital Q. Resultant of two forces not at right angle. By trigonometry, for triangle ABD, we have that AD squared is equal to BA squared plus BD squared minus 2AB times BD cos angle ABD. But cos ABD is equals to, in brackets, 180 minus theta, which is equals to minus cos theta. Therefore, capital R squared is equal to capital P squared plus Q squared plus pq cos theta, where theta is equal to angle BAC, the angle between forces P. Q is equal to 180 degrees minus angle ADB. We are still on resultant of two forces at right angle. The resultant of two forces at right angle is given by r squared equal to AB squared plus DB squared. Triangle forces. If three forces are acting at a point and are in equilibrium, then the sides represent force F1, F2, F3 are concurrent forces. HT. Therefore, representing them in head and tail, we have that the head of F2 is HT and the tail is HT, while the head of F1 is HT and the tail is HT. The head of F3 is HT, the tail is HT. Presenting them in a parallelogram force, we have that they take one of the parallelogram and the diagonal is R, which is F2, F1 and the R. Therefore, starting from the tail, which joins the tail head and which joins the two heads, the head. Parallelogram of forces. The forces acting at a point that are in equilibrium, the forces are represented in the sides of polygon. F1, F2, F3, F4, F5 can be represented in a polygon parallelogram as F1, F2, F3, F4, F5. Example 5. The two forces of 20 Newton and 40 Newton act at a point and the angle between them is 30 degrees. Find the resultant force. Solution. By trigonometry for triangle, we have resultant r squared equal to p squared plus q squared plus 2pq cos 30 degrees. Substituting the values, we have that r squared is equal to 40 squared plus 20 squared plus 2 in bracket 40 times 20 cos 30, making r the subject of the first formula. The square root will now cross over to become square root of in bracket 40 squared plus 20 squared plus 2 in bracket 40 times 20 cos 30, close bracket. Therefore, r is now equal to square root of 3385.6, which is 58. Therefore, resultant force is equal to 58 Newton. Direction of the result.